Okay, good morning, everybody. So today we're going to talk briefly about coterminal angles, and this is another game I want you to play today. And coterminal, co means with, terminal means stop. So what are two angles that stop at the same spot? And this is our unit circle, and the unit circle has an infinite amount of angles. You can squeeze in an angle. Here's the angle 1 degree, but you can have 1.2 degrees or 17.4 repeating degrees. You could have all sorts of different angles, but the ones that we focus on when we study trig are this one, this 30 degrees, which is pi over 6, 45 degrees, which is pi over 4, and 60 degrees, which is pi over 3, 90 degrees, which is pi over 2, and then the rest are just multiples of the other. So like this one right here, this is 150 degrees. So from here, this is 150 degrees. That is 5 pi over 6. So 5 of these pi over 6s will get you right there. But if you go around an entire circle, you could still land right here. And that's what we're going to practice briefly today. So here, the main denominators are 3, 4, 2, and 6. So we've got pi over 3, which is 60 degrees. But 6 pi over 3 is an entire circle. That's 6 groups of 60 degrees. So that's 360 degrees. So 6 pi over 3, which is 2 pi, that's a whole circle. 8 pi over 4, that's 2 pi. That's a whole circle. Pi over 6, just 1 pi over 6 is 30 degrees. But if you have 12 of those, that's 360 degrees. So that's a whole circle. So 12 pi over 6 is a whole circle, 4 pi over 2. All 4 of these fractions, they all equal each other. They all equal 2 pi. So they're in an entire circle, one full circle. So how we can use these to find coterminal angles. What is coterminal with these two? Two separate examples. Well, first of all, this one is pi over 6, so that's 30 degrees, but 43, an amount of 43 of them. 43 pi over 6s. So how many times would you go around the circle if you traveled 43 pi over 6s? Well, 12 pi over 6 is an entire circle. So really the question is, how many 12 pi over 6s can you fit in here? 3 of them, because the 43 is 36 plus 7. So I can break up 43 into 36 pi over 6. That's 3 whole circles. That's 12 plus 12 plus 12. That's 3 whole circles, and then 7 pi over 6. So the angle 7 pi over 6 stops at the same spot as 43 pi over 6. And then 51 pi over 4, well, pi over 4, that's 1/4 of a pi. Well, how many fourths of a pi do you need for a whole circle? You need 8 pi over 4s to get a whole circle. So how many circles are there in 51 pi over 4? So in other words, how many times can 8 go into 51? And it can go in there 6 times, because 8 times 6 is 48. So when you think of the angle 51 pi over 4, that's the same thing as 48 pi over 4 plus 3 pi over 4. So this is 6 whole circles plus 3/4 of a pi. So 3 pi over 4 is coterminal with this. So 7 pi over 6 and 3 pi over 4 are coterminal angles to these two respectively. So let's practice the game here. So this is my helper on the side. These are all full circles. And let's see, I want to, oh, it's refreshing. Hold on. Okay, oh boy, it's asking for 601 pi over 6. Well, how many times does 12 go into 601? Well, I can think of it as, this one might be easier to think about it as a different way. This is really 600 over 6 plus 1 over 6. And 600 over 6 is 100 pi. So that's just, those are just 50 complete circles. and you're left with 1 pi over 6 left over. So 1 pi over 6 was the one that was coterminal with it. This one is more critical for our class. Negative 26 pi over 3. So we're going clockwise if it's a negative angle. So how many full circles can I squeeze in here? Well, if it's the denominator is 3, I'm thinking of 6 pi over 3. So how many 6 pi over 3s go in here? You can get to 24 pi over 3. That would be 4 whole circles. 24 pi over 3 leaves you with 2 left over. So this is coterminal with negative 2 pi over 3, which is this one. And here, 21 pi over 7, well, 7 isn't one of these special angles. So fortunately for us, 21 is divisible by 7. So if you divide, you get negative 3 pi. And negative 3 pi, negative, so you go down, that's 1 pi. You keep on going, that's negative 2 pi. And you go 1 more pi, that's negative 3 pi right here. Negative 22 pi over 3, this is our last one. So pi over 3, 6 pi over 3s will give you a whole circle. So how many circles can you fit in here? 3 whole circles, because the key number is 18. 18 is 3 whole circles here, because 3 times 6 is 18. So when you remove the 18 pi over 3, you're left with negative 4 pi over 3. So that is the coterminal angle, negative 4 pi over 3. So here's 0, that's negative 1 pi over 3, negative 2 pi over 3, negative 3 pi over 3, negative 4 pi over 3. And then this one you can work out in your calculator for degrees. Now when you're switching to degrees, you just figure out how many 360s can squeeze in here. And this is a silly example, but this is kind of fun to work out. It might be beneficial. So how many times does 360 fit into this number? You can go to your calculator and divide by 360. 360 divides this number perfectly. So all of this huge angle is just spinning around this unit circle many times, but it's stopping right there. And we'll do one more, 40 pi over 6. So the over 6 is a denominator. I'm looking for 12 pi over 6. So how many times does 12 fit into 41? It fits in there 3 times, because 36 pi over 6 would be 3 whole circles. And then what's left over from 36? 5 pi over 6. So where is 5 pi over 6 on here? It's this angle.